All right, this is section 4.1, number 1, and we're supposed to write the terms in order of decreasing degree of x. That means the x with the biggest exponent is going to go first. And then you just keep counting down to the next smallest, and the next smallest, and the next smallest, and then your constant, which is your number, comes last. And we have to arrange things that way because later this year we're going to be doing some things like long division and synthetic division, and even in calculus we have to do this for certain things. So, I mean, this is something that you just automatically should start doing. And so, actually, we've been doing it already when we've talked about quadratics and even lines, putting them where the number comes last and the x comes first, for example. Well, here, if you look, the biggest exponent we've got to combine some like terms, okay? So what I'm going to do is I'm going to kind of combine those like terms, but I'm going to do it in the order of the biggest exponent down to the smallest one. Here we got a square, here we got a square. Well, this is a negative 1x squared. I put it in if you need to, and then you get a positive 2x squared. Well, if you have 2x squared and then a minus 1x squared, that would be a positive 1x squared. So we would put that term first because it's got the biggest exponent. Now, if we're going to combine like terms and we go down, the next exponent down would be 1. Well, the 1's invisible, right? The lazy math guy doesn't write it, but that's why it comes next. It actually is an exponent of 1 on the x terms. So these two terms need to get combined. The like term is the x to the first power. I'm not going to write that one down since we're not really supposed to. But then what you do after you write the like term down is you just take the numbers out front and you add them together. So I have a plus 3 plus a minus 5. That's the same thing as a 3 minus 5, which is a minus 2x, or a negative 2x. But remember, we can say adding a negative 2x is the same thing as subtracting 2x. Now, if you look, we've only got one thing left that we haven't messed with, and that is the constant term 2. The number is called the constant. I'm going to quit saying that now because I've been saying that for years. Hopefully I've got that by now. So the constant term is 2, and it's the very last thing we write down is the constant term. And we're done with that one. Oh, and before I go on, we were supposed to name the degree, and the degree is the highest exponent. So since the highest exponent is 2, we call things with 2's, exponents of 2's, quadratic equations. If you remember, you learned that back in Algebra 1. You would think it might be something else like bidratic, but it's actually quadratic equation. So there was 2 parts to that answer. When we go to number 3, let's do the same thing. I'm looking for the biggest exponent, and I see a 3, and it's the only one with a 3 on it. So that's the term I'm going to write first, 3x cubed. We call that a cubed. By the way, the degree of this, since that's the biggest exponent, this is going to be a cubic equation. Okay? The third degree is a cubic equation. So I forgot to do it on the first one. Got it down already, so we don't lose it. Now let's go down to the next exponent down to be a 2, and I see a 2 here, and I see a 2 here. So I'm looking at these two terms. I have a minus x squared and a plus x squared. Those are going to cancel each other out. They add up to 0. Minus x squared plus x squared is 0. I'm not going to write it down if it cancels out. You could write down 0x squared, and we're going to have to do that when we get to the point where we're doing synthetic division and long division, but right now we're not going to write it, okay? Well, let's go to the next thing down. Since the squares canceled out, I'm looking for an exponent of 1, and I have to realize it's just the x terms. That 1's invisible. So we're looking at this term and this term. I have a minus 3x plus a 2x. Remember, you write down the x, and then you say, what's negative 3 plus 2? Well, it's negative 1, and I'll write that as negative 1 like that. Remember, adding a negative 1 is the same thing as subtracting 1, so we could just write it like that, and we've already said that's a cubic equation. Okay, this next one to me was always kind of confusing when I was learning this. We're looking at this, and okay, you're like, what am I supposed to do with this, Well, the thing about it is if we're trying to determine which one of these has the biggest exponent in it, what we have to do, and I know this sounds really weird because I've been telling you not to do this for a long time, is we're going to add the exponents together on all the variables in a term. For instance, in this first term right here, I'll underline it in red. If you add the exponents together, 2 plus 1 is 3, and 3 is 6. So this is a 6th degree term right here. Let's Let's move, and we'll just look at each term and see which one has the highest one so we know what order to list them in. All right, if you look at this term right here, all these have a 1 as an exponent. So this is actually a third degree term because you add up all the exponents in a single term to figure out what its degree is, okay? Let's see. Then I'm going to go on to the next one. I'm going to put a 1 there. If I add all these together, 2 plus 1 is 3, plus 3 is, this is a 6th degree term. Okay. Now if you get down to the end and you look at that one, and you add all those together, 3 plus 2 is 5, plus 2 is 7. This is a 7th degree term. Now because that's a okay, so what is the degree of this equation? The largest term, the exponents added, the term that had the exponents that added up to the largest amount was this last one. So this is a 7th degree equation. We don't have a special name for that. We just call it 7th degree. Now I know because that's the biggest degree, I'm going to list it first. Okay, so that's a 5x cubed y squared z squared. I list it first because the exponents added up to the most there. Now I'm going to cross it out just so we can kind of work our way down. Now there were some like terms here, and one way you could kind of catch it if you missed it the first time is notice that you got two 6 degree terms. Look at them a little more carefully because just because they were 6 degree doesn't mean they're like terms, but it's a clue that they might be. I have an x squared, I have an x squared over here. On the red one I have a y to the first, on the green one I have a y to the first. On the red one I have z cubed, on the green one I have z cubed, even though it's kind of hard to read. Those are like terms because the exponents, it has the same exact letter and each letter has the same exponent on it. So we're going to have a term of x squared yz cubed, and what we're going to do, since we're looking at this term, let me circle on this term and this term, they are like terms. We say, okay, I have 4 of those things, and somebody adds 2 more of those things. That's a positive or a plus 6 of those things. Okay, so they would come next. And now we've only got one term left. It's a 3rd degree term. We're just going to write it down like that. We don't have anybody to combine it with. This is how I would combine like terms, and that puts it in order from the largest down to the smallest exponents. And then we said that it was 7th degree. All right, on number 15, they gave us 2 different polynomials. Remember, a polynomial means you just have more than one term. So I wrote them in different colors. One polynomial I wrote in green, and the other one I wrote in blue. And what we're supposed to do, they want us to do 2 things. So there's 2 parts to each one of these questions. The first thing they want us to do is add them together. Okay, so add the 2 polynomials together. So that's 3x squared minus 2xy plus 4y squared. I'm going to add the whole second thing. Since I'm adding it, nothing's weird's going to happen to my signs or anything, so I can just write it down like this. Here's the first one, and I'm adding the second one. Well, let's combine like terms. There's a 3x squared here and a 2x squared here. 3x squared plus 2x squared is 5x squared. I'm going to cross them out after I've added them, just so we can see what we've done. Now, the next thing I'm going to list are going to be my y squared terms. We always kind of go biggest exponent down. Well, this is confusing. It's really weird when you get 2 exponents in a single term, 2 different variables in a single term, like we've got x's and y's here. We listed some things differently up in number 7, and here they're going to do it a little bit differently. Just don't be too concerned about it. I've got one xy term, so let me put it next, minus 2xy. Okay, took care of it, so now let me pick another color. Now I have 4y squared plus 3y squared, that's 7y squared. That's what I get when I add them. Okay, all right, now let's look at part B. B wants us to subtract, it says subtract the second from the first. So I'm supposed to write 3x squared minus 2xy plus 4y squared, but I'm supposed to subtract the second one from that one. I'll put this one in parentheses just so you can see it's the first one minus the second one. Now the first one I really didn't have to put the parentheses around it, so I'm going to just write it without it because, there was no negative out front to change any signs. But on the second one, there is a negative out front. As a matter of fact, I've got to distribute that negative to both terms. You can think of it as distributing the negative and write that's a minus 2x squared and a minus 3y squared. If that bugs you, remember you can put an invisible 1 there and say negative 1 times positive 2x squared would be negative 2x squared. And negative 1 times positive 3y squared would be negative 3y squared. And now we need to combine any like terms that we see, and I'll kind of color code it. Let's see, x squareds. Here's x squared. Oh, here's an x squared. No, that was supposed to be a y squared. I miswrote that, didn't I? Here's the other x squared. 3x squared minus 2x squared is a positive x squared. Let me cross them out so we can see what we got left. We'll do this little negative 2xy term first. It's the only one of its kind. We'll write it down. And I'll mark it out. And then for green, I'll do the y squareds. That's plus 4y squared minus 3y squared. 4y squared minus 3y squared is a positive y squared. And we are done.